There once was an intelligent young lady named Miss Bright. She traveled far faster than light. She left one day in a relative way and arrived home the previous night. When I was younger, the big debate in science fiction was if you were a fan of Star Wars or Star Trek, and personally, I quite liked both, as well as lots of unrelated and independent sci-fi. But I loved when the movie Stargate came out and loved the series Stargate SG-1 when it made its way into syndication. This episode isn't about that show or even that specific titular Stargate, but to me it moved quickly into a competitor for best sci-fi franchise with Star in its title and remains a personal favorite and one with a far greater sense of realism than Star Trek or Star Wars often had. The show was set on modern Earth, and one of the problems it had to tackle in later series was how they kept the program secret and dealt with all the new technologies they encountered and tried to integrate into Earth's economy quietly. But one point of heavy on realism was you could only have one operating Stargate on a given planet, and perhaps a backup, and yet these were often entirely abandoned and unguarded. For story purposes, it explains why a 4-person team could casually stride through, but of course, realistically, you would expect that portal to be the center of a local civilization and guarded heavier than Fort Knox. And indeed, that's how they guarded their one gate on Earth, complete with thick steel vault doors and machine guns pointed at the gate and encrypted passcodes to get through. This episode isn't about that show, or even that specific variety of Stargate, but rather on the concept of these in general, and we'll be looking at what science tells us about such portals and also what sort of civilizations might result from them, how it might affect interstellar colonization, and a number of other points that sci-fi often glosses over. For instance, what we would expect to see is that portals between planets would result in empires with a lot less spaceships. They might need them to bring those portals in manually to begin with, but at that point you'd almost expect this sort of seed ship to be an entirely robotic one, especially if the portal could be activated at any point or continuously. And indeed, this is the plot we see in the spin-off Stargate universe, where robotic ships lay gates down between planets and even galaxies, on multi-million-year voyages. But such robots don't need to be even as reliable as a normal space probe in some ways, as you can't just flick on a gate occasionally to check if all is well. You could use it as a telescope to survey the planet before putting its landing pod and gear through to assemble around it, and maintenance teams in EVA suits could go out through the portal from Earth at any time to work on it during its interstellar flight. You could even bundle two together for safety and redundancy. Indeed, you could send it out there by attaching a rocket nozzle, and the fuel supply could be continuously pumped in from Earth, which would really change the dynamics of space travel too. Once the portal is there, it's just a magic doorway. You don't have folks occasionally step through, you run rail lines and power cords right through there, and ship in material and people by train, like we see in Peter F. Hamilton's Commonwealth saga. Or if big enough, you terraform planets by opening a passage between a water planet and a desert one and equalizing them. Space travel becomes much easier, but also largely redundant in favor of gates. Of course, if your gate is more of a classic wormhole, getting in on a planet and safely keeping them there gets very dubious, and you might have to go where the wormhole is, or at best put it in orbit of your planet. Although given the mass of the typical wormhole under known physics, you would generally be orbiting the wormhole, not the other way around. Indeed, generally your entire solar system, including your sun, would orbit one. But first, we should probably start with what a wormhole is, and to cover that we should also begin by noting that there are several different types of them, or other portals that folks have discussed over the years. The best known variety these days is the Einstein-Rosen bridge, and it's probably the most likely type to be able to work, though it might be better to say it is the least unlikely to work. But it is not the first or only wormhole concept, nor does it include all the types of possible portals. Since it is the most discussed, and a couple of the other better known ones are just minor variants or expansions of it, it will get discussion here today. But in many ways, I'd rather focus on the alternative options which are less known. Indeed, there's so much about space and time we don't know that I don't really want to rule out options like simply having a door to a closet in your house that opened directly and seamlessly into a warehouse storage on some other planet, or a ship engine that was simply a portal to a young universe where the Big Bang happened mere moments ago and your ship can accelerate to near light speed with blatant indifference to the tyranny of the rocket equation or conservation of momentum and energy. In this way, even a wormhole that didn't allow signals or objects to pass through, just raw, incoherent matter and energy, might let you better travel through space. This was the method used by the Light Hugger ships from the Revelation Space book series by Alastair Reynolds. They drew energy through a wormhole from a younger universe right after a Big Bang. And there are some hypothetical types of wormholes that essentially are just a connection from the start to the end of the universe, or a universe anyway. Incidentally, the term wormhole didn't pop up until physicists Charles Meisner and John Archibald Wheeler coined the term in a paper they wrote in 1957. And Wheeler was inspired by work back in the 1920s by Hermann Weyl that was not focused on gravity or matter, but rather making one-dimensional tubes from electromagnetic field energy. It wasn't related to black holes, and indeed the term black hole was also coined by Wheeler about a decade after the wormhole. So while wormhole explanations nowadays tend to lean heavily on black holes in discussion, for the first decade we discussed wormholes, black holes were never even mentioned by name. Half a century before that, we get our first formal example of one described under theoretical physics and math from Carl Schwarzschild in 1960, and what he described is basically a black hole. Indeed, the event horizons of black holes have a radius based on his calculation called the Schwarzschild radius. These types of wormholes, named after him, are prone to collapsing if any matter passes through them and would require some form of exotic matter like negative matter to hold them open, otherwise even a beam of light going into one would collapse it. And of course, even in the most empty part of the universe, particles of light from the cosmic microwave background radiation are constantly passing through, so we would not expect these to stick around anywhere naturally. Nowadays, anyway, they could potentially exist at the end of time when the CMB radiation was effectively gone. However, later analysis indicated that we could maybe potentially make small ones that would not be collapsed by a very tiny trickle of electrically charged particles, which would hypothetically let you use these for faster-than-light communication, emphasis on maybe. Now, this is Sci-Fi Sunday, so I'm not going to rattle off the potential problems and paradoxes such a communicator might have, and for today I'm mostly burying my skepticism about any type of FTL ever being possible. One thing folks tend to forget about a classic wormhole using a black hole is that a black hole masses multiple stars, so this sort of technology is still only useful if you can either make micro black holes, which I tend to suspect we can, or are willing to sacrifice whole stars or nebulae to making communicators, which you might be too. Even if your bandwidth is worse than old telephone modems, the ability to send messages at FTL speeds allows regions of galaxies to stay in touch. You might only be able to get away with one such communication hub per 100 light-year bubble, but that still allows some semblance of galactic civilizations to work, and even intergalactic too. Alternatively, as we discussed in our look at Kugelblitz black holes last month, tiny black holes radiate energy and faster the smaller they are. This Hawking radiation puts a lower limit on what we could probably use as a communicator without serious noise issues rendering the device unusable. A 1 megaton black hole is arguably portable, and indeed very much so since it gives off 356 trillion watts of power that you could use for an engine, and it gushes that from a space smaller than an atomic nucleus, so how you're getting a charged particle in there as a message is anyone's guess. Same for making out that particle at the other side from your receiver. Even a billion-ton transmitter, one 10,000 times more massive on its own than a modern aircraft carrier, has just hit the radius of an atomic nucleus and is still spewing 356 megawatts of power out. That's only a millionth the power of the previous example, but still a lot. Great for running a space station, but not for running a delicate signal through. Even here, your particles carrying signals would be like trying to throw a baseball into and through a fire hose that was on. You obviously aren't fitting this transmitter system on board a spaceship, except one of the truly Olympian planet-scale ships we sometimes discuss for trying to colonize other galaxies. It's hard to say how much more mass and less power would allow a signal through, but probably by the time we get one with a diameter of 1/10 of a nanometer, something at the atomic rather than nuclear scale, and massing 34 trillion tons, 200 times the mass of Mount Everest, it is down to generating just 314 milliwatts of power and this feels a lot more plausible. Thus, something in the trillion-ton scale, maybe even low trillions or upper billions, but possibly even high trillions, seems like a viable mass range for a black hole transmitter. As to coming up with the mass, as huge as 200 Mount Everest sounds, and it is, this is about 6 billionths of Earth's own mass, and there are hundreds of asteroids more massive than that. Ideally, you're making these out of some hyperabundant material like hydrogen or helium, or even dark matter, and just a single gas giant like Jupiter should be massive enough to let you make one for every one of the billions of star systems in this galaxy. And presumably they don't all have to be made here, or material could be outsourced from beyond our system. This isn't letting you send huge amounts of trade or troops around the galaxy. Indeed, it isn't likely to let you send very large data files either, though the bigger your black hole and the lower the power it gives off, the easier it should be to get higher bandwidth through. So this probably does not allow regular citizens, or post-human ones anyway, to ship copies of their minds around. And it might be that you really are limited to kilobyte scale transmissions of raw text and very compressed images. The hyperspace bandwidth generators of the Battletech or Mech Warrior setting work inside this communication limit, sending messages more akin to texting or telegraphs than Zoom, and where a single letter in an interstellar transmission might be as costly as putting in an ad of the most expensive newspaper. So regular citizens were not sending a lot of messages. Even a wealthier family might limit communication to a single sentence or two, informing a distant relative that someone was very ill or dead. Of course, in that setting, they can jump through space with huge ships from deep out in space, so they can still bulk transmit stuff cheaper, if slower, Pony Express style. And depending on your bandwidth with such communications, you might still do this for things like arts and entertainment or bulk messages. Send them slowly, or maybe send one copy across the galaxy to a dozen major hubs where you can go the rest of the way at light speed to the nearest million worlds. This again is the Schwarzschild wormhole, and you'll see it described, often vaguely and inaccurately, a lot in somewhat older sci-fi. And the Einstein-Rosen wormhole gained in popularity in both science and sci-fi in the last few decades though, and it tends to be the one folks are referring to now if they are trying for scientific realism. Much of this comes down to the idea of a traversable wormhole, one that won't collapse if you enter it or utterly destroy you, and ideally one traveling to elsewhere in your own universe, though arguably a traversable wormhole to another universe is even better, as it is a whole new universe, and also doesn't raise any paradox or time travel concerns. The Einstein-Rosen wormhole is unstable too, but we think if negative matter turned out to be a real thing, we could stick some inside a black hole to stabilize the throat of the wormhole and let passage occur. Thorne and Mike Morris proposed a different type of wormhole back in 1988. And ironically, folks often think this is the Einstein-Rosen wormhole, partially as the sci-fi technobabble explanations tend to get blurry and confused on it, which is understandable. Even among physicists, discussion of wormholes is fairly uncommon, and even the Einstein-Rosen bridge wormhole and Schwarzschild wormhole often get listed as basically identical. They do overlap a lot, but Schwarzschild's wormhole is a black hole with a singularity at its center, and the Einstein-Rosen bridge specifically tries to go around that singularity. The Schwarzschild wormhole is also usually assuming a non-rotating, totally spherical and symmetric black hole. This is where the exotic matter aspect comes in, as Thorne proposes using it to hold the wormhole open and stable, and that's a major difference and source of confusion, and you can probably see why they get used interchangeably. So too, Matt Visser's wormhole just carries on this idea by using exotic matter to hold things open, but far less than earlier estimates. Something in the Jupiter mass region of exotic matter would allow a 1 meter passageway, though I've seen smaller figures offered too, even much smaller. I generally rely on Enrico Rodrigo's wormhole fact for a lot of my numbers on this topic, as 2005 book The Physics of Stargates, or the Orion's Arms Site's discussion of Visser wormholes, but planetary masses, even Jupiter-scale ones, are still entirely doable for a Kardashev 3 civilization looking to stay in touch. A Thorne black hole is big, incidentally. Gargantua from the movie Interstellar is based on his work, and comes in at 100 million solar masses and would be nearly 400 million miles across, and 25 times more massive than our own central black hole for the Milky Way, albeit not as big as the current record holders for largest black hole. If you're wondering why that mass, it's because the tidal forces of black holes, the bit that rips you to pieces, get weaker as the black hole gets bigger, and that's the mass range needed to allow you to pass through safely. Though as I recall, that would actually be the amount of negative or exotic matter required to stabilize the throat at something bigger and mild enough we could pass through. And that's not even a thousandth of mass of our galaxy, so it would be believable that an interstellar civilization might force-feed galactic cores to allow such travel. Or that later in the universe, as these naturally get bigger, they may be used to let people travel between galaxies even as Hubble expansion makes them spaced too far apart for light to ever reach. Alternatively, Visser's Lorentzian wormholes use way less mass and exotic matter, and starts making them plausible in the same sorts of mass ranges we were discussing for micro-black holes of the Schwarzschild variety used for communications only. It also lets us start finding ways to avoid these gateways being used for time travel, which is a bigger issue. The basic reasoning usually goes that any wormhole has two mouths, and if you move one, the clock at it is going to begin slowing down during transit. Under normal special relativity, very fast objects experience less time. If we send it to another system 100 light years away at 25% of light speed, it will arrive 400 years from now in the year 2424, except the clock and calendar there will be 13 years slow and think it's 2411. People stepping out there will read the local clock, think it weird, and if the wormhole is two-way, which is not guaranteed, many theories make them one-way, then they could step back through and see the same time they left at. No problem here. But if you take that wormhole back home where it was created, it would arrive in the year 2824, and its own calendar would say 2798, 26 years behind. And when we set the two mouths near each other, you step into the one in 2824 and out into 2798. 26 years back in time, though never earlier than the time they were first created. Some wormhole approaches do prevent time travel hijinks, and again, these are specifically the ones allowed under basic general relativity. Start throwing in string theory and other options can change. So too, if you're simply opening a portal to another congruent universe that's smaller or has a higher speed limit, traveling there and jumping back into this universe. We looked at that option more in our Floating Space episode and Cheating Reality in our FTL series, but we usually call options like this either floating space or entering hyperspace. Another method to avoid time travel hijinks without hyperspace is to simply keep both mouths further apart in space than they are in time, creating space-like curves instead of time-like curves. If those earlier wormholes are 13 years apart in time but never get closer than 13 light years in distance, no object or signal can return to the original wormhole before it departed. And if we assume these wormholes would naturally fizzle out if you brought them closer or lose the connection by some unknown physical law, you would have no time travel issue, and this is often assumed the case with examples in science fiction. Or that for some reason the clocks stay matched at both ends regardless of relativity. Now this also raises the issue of what shape these mouths are, and while in fiction they tend to be 2D portals you pop in and out of one side of, in most cases they are going to be 3D. Probably spherical, though in some cases they could be squished or extended in one axis or asymmetric, as event horizons of black holes are typically not quite spheres either. When we talk about holding their throats open using negative matter, I think folks imagine a ring on some long corridor, but imagine instead simply two spheres, the mouth and the other mouth, and down deeper in them is another pair of spheres that in reality overlap. Being in one is being in the other, and you could imagine a thin shell of negative matter here, or maybe something like a wiffle ball with lots of holes you could pass through. But Visser's approach is to use a ring or torus of negative matter because it uses less negative matter than a sphere. Incidentally, you probably do not want to waste too much time trying to visualize these things. The whole point of them is that they screw with normal geometry, so outside of mathematical formulae, they're not going to be intuitive, and if you feel like one is intuitive, you are probably misunderstanding it. In this context though, the intent is to create a black hole and then drop negative matter into it to turn it from a non-traversable wormhole into a traversable one. Nothing about that tells us where that wormhole's other mouth is at and if it's one way. And if it is one way, you're going to be making a leap of faith every time you enter it, since your probe or explorers or colonists cannot send a signal back except the long way around, which might be millions of light years away, or more. Other options could have a flat portal. It might be a circle or ellipse or rectangle, but this is not how one deriving simply from Einsteinian relativity is going to look. That's going to be essentially spherical. If you can see through it to the other side, it's going to either be two-way or you're at the receiving end of a one-way tunnel, which means you bury that inside fortifications in case anyone decides to visit, and you do have the defensive edge that they can't see you. They probably send through probes, and maybe ones with instructions on building your own portal to reply to them and say hi, or the probe is designed to build such a thing itself. Now, when it comes to using them for power or as weapons, that's a lot more limited for these types of wormholes. In almost no case can you run tons of power through one of these things without destabilizing them, so as tempting as it would be to take on the end of a wormhole and stick in the core of a star and the other in the back of a spaceship or a power plant, that's not likely to ever work out. Alternatively, you can take a regular old black hole and generate amazing power from it as is. On the flip side, if it really is a portal like in Stargate, then this trick works fine. So does opening one end under the other and dropping a ball down that enters the lower mouth and drops back out the upper mouth and just keeps speeding up, as it falls and resets up top over and over again. But with one that operates under general relativity, that ball would actually slow down when it went back up to the higher wormhole mouth. While we only think of them as portals or doorways, they appear to offer some insane abilities. In practice, those operating nominally under known physics don't get to have those cool cheats. It raises questions like if you jump through a wormhole and emerge in space a billion light years away, where Hubble expansion is moving everything away from you at 7% of light speed, do you emerge stationary relative to that place, or blast out of it moving 7% of light speed? Do you pick up the speed of the planet you're stepping out onto that's rotating a very different speed and angle than your world was when you left, and several thousand miles per hour in a different direction too, for a fiery entry? And another thing to remember is that you are entering a high-mass object and falling toward a singularity. Even if you do skip around it in an Einstein-Rosen bridge or Thorne-stabilized one, you then have to move out of it on the other side. This transit is not instant in any way. You are covering a real physical distance, albeit one very warped relative to us. Essentially the wormhole's event horizon diameter at a minimum. In many wormhole scenarios, your transit could take months, and months you experience too, not just jumping around it to your delivery date on the other side. And again, there's nothing letting us pick these destinations. Even the assumption you could make one with two mouths and tow it to your preferred destination is doing some hand-waving. The exception here is cosmic wormholes, which are those that might have been created when the universe was mere instants old. If these are real, these wormholes would naturally exist as part of the universe's fabric. Their locations would be determined by natural processes in the early universe or the dynamics of space-time. Such wormholes would have locations that are accidental or inherent to the universe's structure. However, you could potentially predict them, and even if they are one way, it is very likely folks would be dumping through probes that would say where they were, which might be so far away in space and time we couldn't tell. But you do not need to know where your own ones go to know they work if you got probes from other people emerging from other ones popping through, or even just coherent signals. Which could be natural. If radio signals and probes can come through, then so can astronomical data, and you could tell if one was moving you through time by examining the CMB radiation coming through it and seeing if its redshift matched the factor we would expect from the spectrum of whatever stars we could see through it too. Here are some hydrogen lines, here's some CMB, hey this wormhole is from 4 billion years ago, or hey everything coming out is redshifted to 28% of light speed, or hey this one is from the year 1 trillion in the future. If a signal can pass through, then we can collect useful information even if no one is transmitting on the other side, and we can't step through ourselves to the other side or send a probe or signal. A two-way traversable wormhole does not have an event horizon on either side incidentally, and a one-way wormhole would seem to have an event horizon on the side you had to jump through, looking like a black hole, so again, a bit of a leap of faith there. We also have quantum wormholes, and indeed some theories think the entire spooky action at distance phenomena might be the result of these, but it's kind of inherent to these theories that using them to send useful information is impossible, let alone people in spaceships. One last note on scientific realism for the day before we get into discussing civilizations using Stargates, and that's on negative matter. Now, the idea here is that this stuff repels mass rather than attracts it gravitationally, and thus can counteract gravity. But the problem is that while it works on paper, so does a $-1 bill, or a negative gallon of water, or a negative cookie. We have never found any negative matter, nobody has ever carried a negative gallon of water, never fed a negative cookie to Santa Claus, and a $-1 is called an IOU. In physics, we have positive and negative charge, but this is simply the opposite charge. We could have called it A and B or red and blue and left out the negative connotation. That said, there are reasons physicists discuss it seriously, such as the Casimir effect, and we deep dived into that in our vacuum energy episode. I am very skeptical of any negative matter actually existing though, and thus I don't really give the Thorn or Visceral wormholes any more credence than other varieties from different cosmological models or even fictional ones. Though with no disrespect to either gentleman incidentally, I don't believe either has ever said they thought such wormholes were very likely either. They're just a fascinating possibility worthy of theoretical exploration. The same could be said of a Tolman wormhole, which opens to the end or beginning of the universe, often called a universe with a bounce, or a Krasnikov tube, and again, see our FTL series for more discussion of those. But let's imagine for a moment that something like a Stargate was around, as opposed to a Thorn or Visceral wormhole. Incidentally, a Stargate was used by Arthur C. Clarke in the 1968 novel 2001, and the 1994 movie with Kurt Russell in it further popularized the term. It makes a bit more sense there, whereas in the Stargate franchise, they're essentially planet-to-planet gates that basically circumvent a need for developing space around stars. We don't see it in the film, but in the 2001 novel, Dave Bowman goes for quite an existential ride through ancient alien empires on his trip through the monolith and space and time, a scene the film represents a bit strangely, albeit in a very Stanley Kubrick sort of way. In any event, we don't get to see much of the monolith builders there or elsewhere in the 2001 series. They're kept pretty mysterious, which is usually a wise approach in writing ancient powerful aliens. Indeed, the ancients of Stargate probably should have been kept more wisely obscure rather than filling in some dots on them. But what would a civilization with Stargates be like? It matters a lot if they can open a gate anywhere or if they have to fly the device there. And if one can be opened, can we pick where it goes, or is it to a random location anywhere in this universe, or even a different one, and does shutting it off lose the connection for keeps? In that last case, you not only have to worry about some accident shutting your gate off, you also have the issue of planets wanting their independence being able to just close their gate down, though that could also be seen as a positive aspect of these devices. There's also not much reason to assume they would stay tethered to a planet or star system they were made in. They might be gravitationally bound to a spot and conserve angular momentum so that you could stick them in some building on a fixed point of a planet, or you might have one that had fixed locations inside a galaxy and once made, they stayed there even as stars migrated around. All of these places have a big effect on how your interstellar empire plays out, and if for instance you can dial up any place randomly in the universe, which may include way beyond the cosmological event horizon, you have an empire that has no internal neighbors except by node connections to the gates. In Stargate, you can only have one gate per planet and it can dial any other, which would tend to imply you had preset schedules for when each planet is getting dialed up or dialing in, and probably you have a crash team ready to go throw a rail line connection and a power cord plug down as soon as a connection establishes so everything can pass through quick. It also implies a hierarchy of planets. In Stargate, you can only keep the connection open for 38 minutes, which means 37 full-length openings a day or 265 a week. Maybe you left a short time gap between each for emergency calls and updates, and if it were one way, like in the show, you might have Earth connecting to 18 planets daily, once coming and once going about 12 hours apart, or do it weekly for 232 such connections. Those 18 Tier 1 planets, or 232 if twice-a-week contacts was sufficient, could then each have 17 or 232 other planets they each serviced in Tier 2, for Earth and 325 more Tier 1 and Tier 2 worlds, and 5,527 worlds in Tier 1, 2, and 3, etc. for daily contact, and weekly would be 71,225 Tier 1, 2, and 3 worlds combined. Incidentally, security and common sense would encourage you to have at least one other planet that regularly dialed those other planets, both in the tier below them and those lateral as well, so maybe each tier is reduced in size to half. They need not necessarily dial with the same frequency. Obviously, this Stargate scenario is very specific to the 38-minute arbitrary value from that show, and the idea that you can only have one portal per planet. You can probably only move 1,000 folks through in a given 38-minute opening too, or in that order of magnitude, so moving between planets might be rather limited and pricey. If, on the other hand, you can have hundreds or thousands of such gates on a single planet and permanently open, then you probably still do a tiered system as you get big enough, but you might have some unexpected planets on that list. Garbage worlds come to mind, as you might have a place that is just not a decent candidate for terraforming, but on which you can slowly dump waste until it reaches a useful level for active mining. It might even be a place you plan to terraform but want to bring the mass up that way, and when you get to the right zone, you switch from garbage to some equivalent of burial material, followed by topsoil. Indeed, you might have portals on the backs of large land conveyances or even planes that were dumping material down below them in an even spread. You might generate rain by opening one to an icy body in an Oort cloud and dropping chunks of ice from 10 miles up to thaw and switch to rain during the fall, or force to a hot planet and into a water reservoir there then to Earth. All while portals in the deep sea help remove excess water and to some planet that needs that water and salt. Everything would just depend on how easy these were to make and maintain, and you might have folks commuting in from a suburb planet to the Ecumenopolis on Earth it's essentially a suburb of. Indeed, you might have nations on Earth where it was just some city like Los Angeles that actually had hundreds of worlds connected to it 1 or 2 steps away that made it a city here but a multiplanetary empire in total. And again, they might not even be in the same universe. You could have portals opening up to another universe for raw materials or energy, or to run heat pumps to shift entropy around, or to take advantage of different physical constants to create materials that wouldn't otherwise work. You could use something like this to create a computer that sprawled over 1 million worlds and multiple chunks of various universes to form some sort of supermind that surpassed a Jupiter brain or even a Matryoshka brain. There are no obvious limits as to how sprawled out such an empire might get to be, or how often entire chunks of it might sever their connections to go their own way. If physics allows such options, it means we have a path forward to virtually endless possibilities among countless worlds. So we're exploring some options for galaxy-spanning gate networks and civilizations. And in this month's Nebula exclusive, Galactic Beacons, we'll ask if stellar empires might create beacons and how those would work, what types there are, such as for SETI purposes or to warn of danger or territorial markings, and what the advantages for and against building them are, and how we would find any if they currently exist. Galactic Beacons is out now exclusively on Nebula, our streaming service, where you can also see every regular episode of SFIA a few days early and ad-free, as well as our other bonus content, including extended editions of mini-episodes, and more Nebula exclusives like last month's episode Crystal Aliens, Topopolis the Eternal River, January's Giant Space Monsters, December's episode The Fermi Paradox, Hermit Shoplifter Hypothesis, Ultra-Relativistic Spaceships, Dark Stars at the Beginning of Time, Life as an Asteroid Miner, Nomadic Miners on the Moon, Space Freighters, Retro Causality, Orc OR and Free Will, and more. Nebula has tons of great content from an ever-growing community of creators. Using my link and discount, it's available now for just over $2.50 a month, less than the price of the drink or snack you might have been enjoying during the episode. When you sign up at my link, go.nebula.tv/IsaacArthur and use my code IsaacArthur, you not only get access to all the great stuff Nebula offers, like Galactic Beacons, you also be directly supporting this show. Again, to see SFIA early, ad-free, and with all the exclusive bonus content, go to go.nebula.tv/IsaacArthur. So today we explored tunnels through space, and this Thursday we'll explore a different type of tunnel, the immense lava tubes on the moon, and what life in those might be like for lunar settlers. Then we'll finish out the month with a pair of episodes looking at colonizing white dwarf star systems, bringing new life to those dead stars, and binary star systems. and their unique challenges with habitable zones and stability. If you'd like to get alerts when those and other episodes come out, make sure to hit the like, subscribe, and notification buttons. You can also help support the show on Patreon, and if you'd like to donate or help in other ways, you can see those options by visiting our website, isaacarthur.net. You can also catch all of SFIA's episodes early and ad-free on our streaming service, Nebula, along with hours of bonus content like Galactic Beacons at go.nebula.tv/isaacarthur. Thanks for watching, and have a great week.